Hi everyone. In this video, I'll introduce Vectrum, a very powerful SDF system in OctaneRender. Let's get started. First, let's add a plane. Let's rename it Vectrum. Now let's add a material for it and call it Vectrum as well. Let's get rid of the universal material node, and from the geometry folder, let's add a domain transform attached to the displacement input. We can now specify the Vectrum material and the domain transform node. Let's now add our first Vectrum primitive, a box, and let's connect it to the SDF input in the domain transform. Clicking on the plus button next to the transform input will add a 3D transformation node. We can now use the values of this node to rotate, translate, and scale our Vectrum primitive. Width, height, and depth can also be changed in the box node. Now, let's add a universal material. We can connect it to the material input in the box node. We can change the color of the albedo, the metallic value, or any other material attribute. Now, let's add a union node. We attach it to the SDF input in the domain transform and plug the box into the input one. Let's also add another primitive, a sphere this time. And even in this case, we're going to have a transform node and translate the sphere on the y-axis. Each primitive has its own modifiers options, like, in the box case, we can change this value here around base, or just round, and get some useful variation in the shape. The union node let us specify a radius value, which controls the blending between the primitives. That's a great feature offered by SDF in general. We can build complex shapes using the primitives and combining them using different nodes like union, subtract, intersect, and so on. By the way, moving around the primitive using the 3D transformation nodes is not ideal. So let's make it more comfortable. Let's add an empty with a shape set to sphere, and also add another one with the shape set to cube. After selecting the vector node, let's get rid of the two 3D transformation nodes. We can now add an object data node and select one of the empties. It's very useful, of course, to rename the empties correctly. So box and sphere. And we can now connect the transform out of the object data to the transform of the sphere primitive, and then select the empty and move it in the viewport to verify that everything is working as it should. Back in the vector node, let's duplicate the object data, select the box empty, and connect it to the transform of the box primitive. So now we can also move the empty related to the box primitive and see the result in real time. We can scale it, we can rotate it, and so on. Using the object data node transform out along with empties, it's of course way more practical than using the 3D transformation node. Let's select the Vectron item again, and let's duplicate the universal material and connect it to the sphere material. So we can change something and see how also the materials are blending correctly. We can, of course, change any of the materials attributes, like, for example, the roughness or the metallic. And the blending effect is really, really cool. Let's also change the albedo color of the box. Add some metallic to it. And yeah, it's just great. In Vectrum, we can combine several primitives using different operation like union, subtract. In this case, let's add a subtract node just after the union node and a new primitive, torus. Let's attach it to the input 2. And you can see it's here, but let's create an empty for it so we can move it. Let's use a cube in this case, but let's name it toroid. Okay. Back in Vectron, let's duplicate the object data node, connect the transform out to the transform of the toroid primitive, and select the toroid as empty we want to use. In this case, it's very important to set the primitives to Octane more than Blender to have a correct representation of the toroid transformation. So you can now see how we can use the toroid to subtract from the union operation of the box and the sphere. We can change the major radius and the minor radius of the toroid, of course, but also the fill. So you can see how that works. And in the subtract, we find the radius option as well that can smooth out the final subtract operation. Now, let's add another universal material. So we can connect it to the material input in the torus node and use the transfer material option in the subtract. Now you can see the effect on the shape. Let's add the filter once so we can clearly see what it does, and let's move the empty around. So as you can see, not only the shape is subtracted from the previous union, but the intersection is colored using the material attached to the toroid. Let's take a look at some other operation we can perform in Vectron. And let's add an offset node. Let's create some space. And as you can see, the offset node can basically offset the geometry. And that can be done in both directions. Now let's add an intersect node. And we can connect the union to it and then use the torus as an intersection primitive. And now you can see that moving the toroid around will just show the intersection between the toroid itself and the previous Vectron operation. Next node, inset. Let's get rid of some of those nodes here. And I'm going to connect the union operation to the input 1 of the inset node and then toroid to the input 2 and the inset node to the SDF input in the domain transform. We can now play with the toroid and see how the inset is changing the shape. I can also change the offset and the radius options and create a very interesting bevel effect. Now let's take a look at the ink operation. So let's add an ink node. And with this node, we can basically paint the source object using the shape from another one. And as always, any material attribute would be applied. The radius option in this case helps smoothing out the final result. At 0 it's very sharp, but yeah, we can have a very smooth blending between the different materials. We can also use a clipping plane to cut the Vectrum primitives. Let's add a clip node. And let's see how it works. So we have the show clipping plane option that can be turned off. And using a transform node, we can rotate and move the clipping plane around. So this plane is going to cut our Vectrum primitive. And also in this case, we have a radius option that can smooth out the cut. Now, before showing the most exciting feature of Vectrum, only available in Octane 2025, let's rebuild a very simple setup just using the union and subtract nodes. The new feature I'm going to show you is called Vectrum displacement. So let's add the Vectrum displacement node and let's connect the geometry output of the subtract to the input of the Vectrum displacement. So now, what we're going to do now is to add a noise texture and connect it to the texture input in the Vectrum displacement. And immediately you can see the displacement taking place here. We can add a transform to the noise texture, so we can change the scale. We can change the gamma. And again, this is really exciting. We can, of course, change the displacement height. And the offset. And we can move the primitives around. I enjoy experimenting with noise texture attributes to create visually striking and dynamic displacement effects. The new Vectrum displacement is for sure a great addition to the Octane feature arsenal. In this video, we just scratched the surface of its power. Vectron really offers a lot of possibilities. I've been working on some very interesting advanced Vectron projects you can find on my Instagram profiles. I'll make some specific tutorials showing how to achieve the same results. Meanwhile, I hope you enjoyed this video. See you next time. Bye.